All right, another day of Precalculus. Today is our first day of new knowledge. James is our game warden. Thank you, James. Is there a quiet raised hand that can read the objective for us, Eva?
Find complex conjugate and divide complex numbers.
There it is. Conjugates. Ooh, scary word. Complex numbers and division. You might notice that there's a giant lack of division yesterday. We did multiplication. We've done addition before. We've done subtraction. Today we're doing division. In order to do division, you need to use complex conjugates. Jaden, on your way out, take off the magnet, please.
Oh.
All right, so let's talk about what the conjugate is. If I was talking about just normal polynomials, there is such thing as a conjugate pair. Raise your hand if that sounds familiar. Have you heard of the term conjugate pair before? It's whenever you factor a difference of squares. For example, if I don't write this down, if I had x squared minus 4, the conjugate pair factorization is x plus 2, x minus 2. Those are called conjugate pairs. The only thing that conjugate means the sign in between changes. So if I come back here to the definition of conjugate, what am I doing? Conjugate is changing the what between the two terms. I just said it. It starts with S, four-letter word. Change the what between the two terms? Fiona? The sign. Thank you, Fiona. Everyone write down the sign. So Fiona's gotten her XP, Eva got her XP. You got it, James?
I'm not going to use that pen.
This pen? Or this printer?
Yeah.
It's not Wi-Fi, it's not AirPrint. Oh. Nice catch. Fast hands. All right. So the complex conjugate is a little bit different. Instead of changing the sign in between the two terms, I mean, that's correct if you're writing it in the A plus BI form. Can you write off here? This is A plus BI form. Do you write this down? You need to write it correctly, and then it's the term in between the two, or it's the sign in between the two terms. But the homework tonight is not going to give you this form. In fact, most of the time they'll give you BI plus A. That's not the right way of writing it. You should be writing real, then imaginary. If you write it the correct way, then again, it's the same definition. Just change the sign between the two terms. To make it easier on you, change the sign, well, I give it away, the sign of the I term. That means if they give it to you in this backwards form, change this sign right here. Most people only think it's a second term. No, it's the term in between if it's written correctly, or just change the sign of the I term. So far, so good. Chris Hood. Chris Hood. Thank you, Gio. So, let's go on to example number 1. I need to find the oh yeah, and by the way, the way that you write a complex conjugate is with a giant line above it. So when you're talking about complex numbers, if you write a giant line on the top, that means you're doing the complex conjugate. So I need to find the complex conjugate, this bar Z1 of Z1. Is there a quiet raised hand? Who can think that they can do that? Who can find the complex conjugate of 3 plus 4i? Andrea, go for it. There it is. 3 minus 4i. Thank you, Andrea. Yeah, you could do it at the gym. That's fine. All we did was change the sign. That's it. Easy XP. Thank you, James, for logging the XP. All right, and then example 2. Who can try this one? This one is a little bit backwards, so it's a little bit tricky. Who can find the complex conjugate of 2i minus 8? Someone new. Someone new. Yeah, Gio, is that your hand? Ooh, careful. So it's not the second term.
Oh, wait. All right. Hold on.
Go for it, Gio.
8 wait. Never mind.
So look at the I term, Gio. There's your imaginary term. Change that one.
Negative 2i minus 8.
There it is. Negative 2i minus 8. Thank you, Gio. 50 XP to Gio. This one was written backwards, and that's the reason that we changed the sign of the first term instead of the second term. So far, so good? All right, so on a graph, you're going to do what over the what axis? So let's come down here, all the way down here to example 3. Is there a quiet raised hand that can tell me what is this complex number? It's something plus something, or something minus something. James, go for it.
4 plus 3i.
There it is, 4 plus 3i. Thank you, James. 50 XP to yourself. I need to find the complex conjugate. Quiet raised hand. What is the complex conjugate of 4 plus 3i? Eva. 4 minus 3i. So graph 4 minus 3i. Thank you, Eva. So this is Z1 with a bar over it, and that is 4 minus 3i. So far, so good. Are there questions about what we just did? No questions? So what did we just do? Did we rotate? Did we reflect? Did we dilate? What did we do? Quiet raised hand. Geo again. It is a reflection over which axis? Over the, well, it's not the x-axis, it's now the real axis. If you reflect over the real axis, that is the graphical representation of the complex conjugate. So far, so good? So there's two different ways. There's the algebraic way where you switch the sign of the imaginary, and then there's the graphical way, which is reflecting over the real axis. You need to know both of those for the homework tonight. Let's go to the back. This is the hard bit. That first bit was easy, reflecting and changing a sign. You know how to do that. This is the difficult form. It is bad form to have imaginary numbers in the, if I have a fraction, guess where it's bad to have it, just like with radicals. Quiet raised hand. If I have radicals, radical 2 over radical 2, which one of these is bad? The numerator or the denominator? Quiet raised hand. It's the same thing for imaginary numbers. Quiet raised hand. Where is it? Fiona, go for it. It is indeed the denominator. The denominator. So just like radical fractions, you cannot have radicals in the denominator, nor can you have imaginary numbers in the denominator. You're allowed to have real numbers in the denominator, just not imaginaries. Well, I mean, you can have them, it's okay, but in order for it to be proper, don't have that. So, in order to get rid of the imaginary number, you're going to multiply by the, what thing did I say you needed to have in order to do division? I said at the very beginning of the lesson. Look at the objective. When we read the objective, you need to learn this one thing in order to do division. Quiet raised hand. It's a thing we just studied for the first half of the notes. Quiet raised hand. Is there more than just Eva that has it? Eva, go for it. Say it louder. Complex something. Say again, Eva. Complex. There it is, conjugates. Complex conjugate. All right. And of course, we can't just multiply by the complex conjugate. We have to do complex conjugate divided by the complex conjugate, so we're multiplying by 1. So here's your division problem. I'm going to do example 4 with you. You will do example 5 by yourself and with neighbors. So, example 4. I don't like having an imaginary term in the denominator. Not good form. So I'm going to multiply this whole thing times something over something else. Something over itself, I guess. Because you're really multiplying by 1. If you multiply by 1, it's the same thing. So can someone tell me what the complex conjugate is for the denominator? Quiet raised hand. For the denominator, negative 4 minus I, what is the complex conjugate? Andrea. Negative 4 plus I. And in order for this to be 1, I also have a negative 4 plus I in the numerator. Chris Hood. So far, so good. Okay, and now you have to review how to multiply complex numbers, which was from yesterday. So, to multiply complex numbers for each of these, I need to make their own little area model. All right, I'm going to do the numerator here. I'm going to do 11 plus 24i, 11 and 24i. And I'm also going to have negative 4 plus I, negative 4 and positive I. All right, everyone can get XP because we're all going to shout them out unless Eva does it all again. So 11 times negative 4 is?
Negative 44.
Perfect. 11 times I is? 11i. 24i times negative 4, it's a little bit harder. You got this. Negative 96i. A little bit harder to shout out. And this last one, you're allowed to use I squared. Tell me what this last cell is. 24i squared, which simplifies to negative 24. All right, I'm going to pause. Let you catch up. Looks like we have an answer for the next part.
What's the thing?
Pinching down with the fist. There. Oh, a question. Yes, Fiona.
Oh. So, are we just ignoring 11 plus 24? Oh, wait. I take it back.
Ah, you see, yeah. So the 11 plus 24i, this guy came down to the left-hand side.
Wait,
Question again.
so we're multiplying instead of equal.
Multiplying, say again?
It's not an equal sign.
Well, yeah, it says it's equal to. We need to do some math in order for it to equal something else.
Oh.
Yeah, so kind of ignore the equal sign for now.
Okay.
Good question. All right. Is there someone that can do the area model, combine the diagonals, combine the like terms? What is the area telling us it's equal to? Combine negative 44, 20, negative 24, negative 96 with 11, and you get what areas? Or quiet raise hand that can just do addition and subtraction? James, go for it.
Negative 68.
Negative 68. Negative 85. All right, there it is. All right, so the area model tells us that the numerator, when I multiply 11 plus 24i times negative 4 plus I, that will equal now James's negative 68 minus 85i. Questions? Let's do it again. I need to do an area model for the bottom, unless you're really good at foiling, in which case you can use foil if you like. Area model with negative 4 minus I with negative 4 plus I. I'll let you set up your area model, and then we'll start shouting them out again. Oh yeah, James, can you give, when you have time, everyone 40 XP? I still need to change that preset. Cool, thank you. I'll do it later, okay. All right, we're gonna shout these out. Is there a question? Is it a question, James, or are you ready to? Yeah.
Is it supposed to be positive I instead of negative?
Oh yeah, so I just did them backwards. I did my negative I there and positive I there. So this one is a positive I, this one is a negative I.
Oh, you're doing
Yeah, we're multiplying by the complex conjugate, so one of them should be positive, one of them should be negative. All right, let's start shouting them out. Negative 4 times negative 4.
16.
All of us together in this next time. Negative 4 times negative I is 4i. Negative 4 times I is, and finally negative I times, you can use I squared again. Negative I times I is negative I squared, which is 1. Perfect. All right. Quiet raise hand. Who can help me find the area? Miss Godoy?
16.
What'd you say? 16 or 17? Okay. 17. Notice that there's no imaginary term, which is the whole idea. You don't want imaginary numbers in the denominator. And look, there's no imaginary terms now. It's just 17. So this denominator now is 17. Question, James?
17.
So I'd added the 16 plus 1 to get 17. Negative 4i plus 4i is 0i.
I thought you wrote it as
Okay. We're not done. It seems like we're done, but we're not, because we now need to reduce. What times 17 is 68? Yep, so I have, this is now equal to negative 4, and then what times 17 is negative 85i? Negative 5i. Final answer, box it. Always be careful. You need to simplify your answers. If you don't believe me, 68 divided by 17 is indeed 4, and then 85 divided by 17 is indeed 5. Preguntas.
No. No, sir.
All right, you guys are on your own. For example, number 5, remember to reduce. Good luck. There were a lot of steps there. I'll be walking around and helping. All right, here we go. So I'm going to multiply the top and bottom by what and what? Quiet raise hand. What am I multiplying the top and bottom by? Quiet raise hand.
5 plus 3. I want to do
Sir, quiet raise hand, please.
Can I use the smart pencil, please?
You want to do this problem? Yeah.
Yeah, but I'm not talking. It's gonna be like,
You have to talk to, though.
Can I do it?
go for it.
If you haven't, yeah, go for it.
I got it wrong. I know that. But...
Then we will catch your error for you,
Okay.
and then you will learn.
You got it.
Hey guys,
Hi.
welcome back to my
Can I
channel.
listen to music or
No,
Catch your error if you
well I'm the recorder right now, so
Oh, we should probably unfreeze it too.
I don't know how to do that.
Alright, continue on.
All right. So
Keep recording.
you do the little box thing. And you gotta multiply those two and those two. So you gotta go 5. Right? Mr. Cinda.
So far, so good.
So this one goes on the bottom? Wait. So that whole thing equals. Wait. That's it. Wait, that goes on the bottom?
What did you multiply? Did you do 5 minus 3i times 5 plus 3i? Or did you-
Yeah. I thought it would go on the top.
Because
That doesn't make
you
sense.
multiply the bottom times bottom to get the bottom. You multiply straight through for fractions.
Oh. I knew that. Is that one? Is that right?
How did you get 57?
I don't know. I don't know.
57.
Oh wait, that's this one.
It's 57.
What's 5 times? Oh wait, never mind. How do I erase?
It'll probably mess you up, but very top middle-ish area, there's an eraser button. Very top
Oh.
middle area.
All right.
There's one more mistake also.
What?
What's 125 minus 57?
This is for XP. Yes, question.
What was it?
125 minus 57.
68.
And then 95 plus 75. That's what I got, Mr. Sindel. Is that right?
Yep.
Oh.
When you can reduce it, you can divide the top and bottom by 2, so you can have 34 plus, what would that be, 1, it would be 34 plus,
Yeah. It's just gonna be
No.
2 plus 5.
170 divided by 2 is that 85?
Yeah.
But doesn't 34 go into both of those?
Does it?
Yeah.
Okay.
So what am I doing?
So 34 goes into
You
68.
get 17 on the bottom for now. You can reduce one more time after this. Because we divide the top and bottom by 2, and then 34 divided by 17, Fiona is 2. So again, you're going to run out of room here. Can you close the pen tool area? Because I think you have more room on the right.
What?
See that pen tool is
Oh.
taking up room.
Boom.
That's equal to, so now 2, and then what's 85i divided by 17?
5.
5. There's your answer, nice. So can you hit Command Shift 2 to end this work?
Bye bye.